Okay, so I realize now that I cannot actually do this without thread pooling. Um, so what I want to do is I'm going to create a new folder and I'm going to go thread pooling and I'm going to copy these too many threads into thread pooling. Okay. That is unfortunate, but here's the thing. A thread pool is actually relatively simple. It's not impossible. I'm just not sure I have the time to do it right now. I've showed you how to create some mutexes and manage threads. Let's just say, for sake of argument, that you're going to keep your threads under a certain limit, right? 30,000, roughly 30,000 is the limit that you should have. If we take this down to 30,000, it runs without error, and we're in great shape, right? And you're like, wait, what? Yeah, all that's happening wrong here is that it goes, the max number of threads are heard, and oh, we still have a what you call it because we're not locking. But anyway, what I was going to say is so there is overlap at some point. So what's happening is that each process has a certain amount of threads it can create, and my mechanism for creating the 300,000 threads, but killing the threads and then recreating them, that doesn't work for the operating systems. That's not acceptable. Um, it is acceptable in some systems. It's not acceptable in C. Unfortunately, it's a low-level one-to-one situation. As a result, there is a hard limit. So those are not completely freed, and as a result of not being completely freed, um, not going to work. Could I join them? Yes, but to join them, I would have to have a data structure in order to join it. And as a result of doing that, I would need signals or some other mechanism to do it. Um, and that's just not going to work. So if I have time, I will do thread pooling. But we do have some other things we need to do, so we're going to do that first. For all intents and purposes, if we never get back to thread pooling, keep your threads under 30,000, and you will not actually run into the max thread pool, max threads situation. And yes, I do have an implementation of a thread pool. Just requires a simple array list. But it does involve some data structures. So I would like to avoid it if I can, because I don't wish to go over the data structures. All right, let's get to P2. So we're going to try to create some deadlock situations. Okay, so there's a very easy way to get there. Yay. And so I'm actually going to use P1C to get to P1, P2. And I talked about this, but I never actually did it. So I'm just going to remove that. Lock. And you're like, wait a second, what do you mean? So what's going to happen is we're going to lock and unlock when the balance is a certain amount. But what happens if the balance goes negative? We run into an immediate problem, right? So what I'm going to do is we're going to have $1,000. And so we're going to run pretty quickly into a situation where we have less than the amount in our account. And pretty quickly we run into a deadlock situation. And you're like, wait, what? Okay. You go, how do you know it's deadlock? So what's happening is I'm locking here and unlocking only in the if statement. And this is a simple deadlock situation. So what happens is one thread comes in, it locks it, mutex, if the balance is less than, great. If the balance is not, it just returns zero. And then you come in with another thread, tries to lock it again and cannot. Okay. And so that's a very, very simple deadlock situation. It's very, very simple. It does not require a lot of work. Let's try to do one that's a little bit more complicated, but it is actually more difficult to see in real life. I don't believe I have it here. Yep, here it is. Actually, it is P6, I believe. Let's give it a shot. And what P6 does is it creates one thread, and then it creates another thread, and then just joins the two. In the joining process, one locks lock one and lock two. The other one locks two and lock one. Obviously, they're in outside of order. What I'm trying to do here is create a deadly embrace. Okay, and I think this is the one that always works. Nope, this one finished. And you go, wait a second, what? It finished. Watch, I'll do it again. Yes, this one also finished. Also finished. Also finished. And you're like, wait a second, what? All right, so I want to show you something really quickly. So it's, oh, they're both creating method one. Sorry. So one of them needs to create method two. Sorry. Right? Sorry. I fixed the deadlock. Okay. Let's clear it. And this should pretty quickly get to deadlock. And we're deadlocked. You'll note there's no movement. It's not actually finishing. That's what it should look like, right? It's not working, but hey, look at that. Never finishes. It's never going to finish. And that's simply because the locks are obtained out of order. So what do we have to do? In deadly embrace type situations, we just have to make sure that we're avoiding the deadlock. Most of the time, that means we're making sure that in every case, so this is the more common thing that we see in real practice is that you have a complicated situation, and while you're locking it, you're not unlocking in every situation. Okay. Another common situation is a situation in which you're locking it in one place and trying to unlock it in a different place or trying to lock it again, what have you. So you need to make sure that you're following your locks carefully and make sure that you're doing that work appropriately. Otherwise, very, 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 very quickly we run into situations. This is one where I do a counter lock. I'm just doing counters. There's nothing special about this. And then I'm doing joins. There's really nothing special about this. I'm just doing joins with locks. Not very exciting. What was happening here is simply put, I was using counters instead of if you look at P2, I was using a balance, but there I was using a literal counter. Um, so this is the deadly embrace. You can see that we're essentially doing the same work. So what I can do is just if I use method one twice, right? If I copy this to P4.C, this is what we saw. Oops. In the P4C, instead of doing method one, instead of doing method two, and this will always finish. And you're like, wait, what? It will always finish. Yes. And you're like, how is that always possible? Right? Doesn't matter how many locks you have, if you're always locking in the same pattern and unlocking in the same pattern, it'll always work. It's the only case you have run into situations and when your locking pattern is different. One of the things that's really important when you have multiple locks is to make sure the locks do not depend on each other. One lock should never depend on each other. And if it does, you need to make extra care that they depend on each other in the same way. Um, so you can make sure, that they unlock in the same way. For instance, if lock two is dependent on lock one, that's great. That means in every situation, lock two requires lock one to already be set, right? And lock one never depends on lock two. So we don't care, right? And so if you just make sure that you have the dependency set up usually and make sure the order in which they're operating, usually you're 100% sure you're going to finish. All right, I'm going to decide whether I do the thread pooling. I'm not 100% set on doing it, but I did actually finish the other work actually faster. And it's just a matter of understanding whether or not thread pool does do the other work does require us to do things we don't want to do. And you're like, wait, what? Um, So I'm not going to show it to you before I double check it, but the basic dilemma is does it require us to use a complicated data structure? If it does, we're not doing it. Is the short answer. Does that mean we can't? No, maybe, but we're gonna avoid it for now. All right. Thank you guys. I'm gonna be back only if we can do the thread pulling. Okay. Otherwise, enjoy your weekend, and I'll see you back on the 11th or 12th. I don't remember the 11th. Okay. Thank you.